Okay, so my name is Tomáš Petříček, and I'll be speaking about accessing loosely structured data. That's a horrible title. Sorry about it. You'll see what it means in a second. So first of all, a little bit about me. I'm author of this real-world functional programming book, which is written for C# developers as an introduction to functional programming. So if you enjoyed the talk on monads, this may give you some more details about this topic and about other functional concepts in general. I have one copy, so I'll have some raffle at the end, because unlike Mark's book, this one is actually printed by now. I did some work on the F# language as an intern and contractor, and my first blog post on F# was from 2006, which is an interesting point. And the problem today, I said it's about accessing data. So when you're accessing data, the problem is that the data source speaks different language than your programming language you're using to access the data. So there's some mismatch between the two languages. In your programming language, you have some classes with properties. If you're programming in C#, you have some data types in F#, which are just slightly simpler concepts. On the data side, you have various kind of things. You may have some database structure. You can have XML files with some explicitly defined schema, or you can have some services, web services, whatever. These data sources, they all have some structure. Sometimes it's described explicitly by some formal description language. Sometimes it's just how the data look that defines the structure. But there's always some structure in the data. And when you want to access these from your language, you have to somehow bridge this difference between how you want to describe data in your language and how the data appear in the data source. So that's the problem for this talk. What I'll talk about, first I'll show you a few things that if you like the word design patterns, it could be viewed as some common ways to dealing with this problem. I'll show you a few interesting tricks you can do in C# and in F#. Things you could implement to bridge the gap. And finally, I'll show you an example of F# type providers. This is a new thing that will be in the next version of F#. So it's not currently publicly available, but I was lucky enough to get a version of it from the F# team, so I can show you some actual examples. And that's an automatic way, in some sense, to solve the problem. It imports the structure from the data automatically into your programming language. So these are the other reasons for staying until the end of the talk, aside from the book that's somewhere in my bag. Okay, so I'll talk about the problem on 3 different scales. The smallest scale is when you're writing some expression in your language where you need to get some data. So you have some data, in this case, for example, XML file, and I need to get some values from the XML file. The compiler doesn't understand XML. That's not something compilers usually do. So you need to somehow explicitly say in your program, what structure do you expect? So this example says that there's some expected type of the data. It's going to be some number. And there's some expected structure. It's going to be an element called, or attribute called size. That's something you can write in your language. The first problem on this small scale is that this really has too much syntactic overhead. You have to write these attribute, you have to write the int type 2 times in your program. And writing larger methods like this, it's really not that elegant. So I'll show you how it could look if we were using the dynamic type that's available in C# 4. And then I'll show you some more examples. So I'll run the example first. I usually do all my demos in console applications, but since I had some spare time yesterday, I need to actually implement it first. Okay. So let's look at the implementation. I have this. It's embedded in ASP.NET MVC framework. You don't really need to worry about that. I just need to implement this method, which returns data for the index page. And I want to access data from the World Bank, which is an international organization that gives you some services for getting data such as national income of a country and so on. It's massive data source of all sorts of data. And I wrote a wrapper that uses the dynamic features of C# to give me nice access to the data source. So I'm creating this World Bank object, which is some magic object that knows how to use the web service. And then I'm calling it. It provides numerous methods. The region methods gives me a list of all regions that the data sets describe. And I'm specifying some argument to say that I want 100 items. And then this gives me back some XML data that I can process. And again, I know the structure of the XML data. I know that it has some regions element as the root, and then some region element which contains the actual data. And by using the dynamic keyword in C#, I can write something like this. So I'll have IEnumerable, some sequence of regions. And then once I have that, I can enumerate over all the elements. And this is really just processing the XML document that I'll get back. Maybe I can actually show you how the document looks. The World Bank service has something called Query Builder. That wasn't very good. Let's try it again. And what I'm currently doing is this query to select regions. And this just generates some URL, and it gives me back this XML file. And I wrote this little dynamic wrapper for accessing XML. So when I write something like this XML.regions, it will give me this root regions element. When I write .region, it will give me all elements named region under this main element. And then I'll get back a sequence of regions. And as I'm iterating over the regions, I can type .name to get this field and .code to get this field. So the dynamic operator really just removes the syntactic overhead that was in the code previously. I don't have to write all the fields as strings, and I can use the compiler infers the type that I want to get from when I assign it to some field and so on. So this is calling this method index. It gets list of regions and returns their names and codes. And it generates this nice web page where I can click on the region, like Euro area, and I'll get, it calls a second function, which is this countries, and it uses exactly the same programming style to get, to call countries method of the service with some arguments. I'm specifying the region code that I want to get, and then it iterates over the XML data and gets me a capital name and the name of the country. And the interesting point is that the World Bank object doesn't really doesn't really have methods like regions, countries. That's something that it automatically finds when I type .countries. So how does this work? When I have some object in C#, and when I assign it to the dynamic type, then C# uses some tricky way of finding members of the type at runtime. So I could write, instead of writing wb.regions, I could write wb.blah, blah, 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 blah. It would still compile it because the lookup for the members on the dynamic type is done at runtime. So this defers the lookup to the runtime, and at the runtime, when the World Bank object is implemented in some special way, it can handle this message or this member access, and instead of invoking a method of a .NET type, I can do anything I want. I can use the name to call some web service, and I can get the results from the web service and return them back. So the easiest way to implement this in C# is to inherit from this dynamic object, which is some special type that's understood by the .NET runtime. And if I override try invoke member, then this handler will be called whenever you access using the dot notation some member of the object. So this really just removes some syntactic overhead I would have to write, and it gives me a nicer syntax for accessing members that will be resolved at the program runtime. Does this make sense, or do you have any questions? Good? Okay, so that's how it looks in C#. And I'll give the examples somewhere on the internet so you can get it and look at it after the talk. I'll show you similar thing in F#. F# it doesn't have dynamic type. It has something called dynamic operator, which serves pretty much the same purpose, but it's done in a slightly different way, and it has some interesting consequences. So in C#, the call using dot on dynamic type is handled specially, and when I'm assigning the result, when I get the result is also something of the dynamic type. So I don't know what the result is. And I can cast it to some required type just implicitly by writing something like this. In F#, I'm using special syntax using this question mark, which means dynamic member invocation. So you can see where the dynamic operation happens. And that's one difference. The other difference is that the compiler infers the type from the context. So when you write something like this, and then use size, for example, in some math calculation, then the compiler will find out that you're using size in some calculation, so it probably must be an integer. There are some ways to specify that explicitly, but it means that the dynamic operator gets the required type, and the operator can do some interesting things with it, as I'll show in the next examples. So in F#, the operation that's going to be called, it's not really resolved at runtime, because the question mark is just some special operator that can be defined by F# types. And when they define the type, then the compiler knows it's going to call this in this implementation of the operator. And the result of the operator can be some well-known type. You can write operator that always returns string, or you can write operator that returns whatever the user wants it to return. So in this example, I'm working with some databases, and I'm writing this getCategories function, which uses db.query, which is defined somewhere else in the code, and it calls the getProducts member on this object. The getProducts method is called dynamically, and this would, in this example, it would call some stored procedure in SQL Server database. And the interesting thing here is that it gives me some row object, which is a statically known type called row, which also implements the dynamic operator in a different way. So it implements it such that the operator gives me the type I want. So when I'm accessing ID, the language, the compiler knows that I want to return sequence containing integers and strings, which is just like .NET I enumerable. And when I write row $ID, it will figure out that I want to get integer, and it pushes the conversion into the operator, so the operator can implement the conversion to read the ID from the database and try to convert it to the type I need. So that's just a minor difference in the way it works internally, but I guess I'll show you a larger example or more complete example that shows how it works in practice. So I have a little application that implements an online poll where I can select one of several options. The database has just a single table called poll options, which contains ID, title, and the number of votes for the option. And then the database has a stored procedure, two stored procedures actually, one for selecting the data from the poll. So get options gives me all the options, and vote has an argument, and it increments the number of votes for some specified option. If you wanted to access this using the things that are currently available in .NET, then you would use, for example, link to entities or link to SQL or something like that, and you would generate some object model in the C# language that describes the database, and then you would use this object model to call the database. But if you're writing something really simple, then maybe this is too complicated. So in this example, I really just need to implement two simple functions. One is to do the voting, and the other is to load the data. And I'm using the dynamic database helper, which is some generic helper that implements the dynamic operator, and that can be used generally for any databases. So the vote function, it's written in F#. So module is, you can think of module just as a static class. And if you write let inside the module, then you're creating a static method, essentially. So this is just implementing some static class in the C# terms that exposes the access to the data. The declaration above, the poll option type, that's something called record. And that's essentially just a class containing only 4 properties and nothing else. So to implement voting, I'll get the ID of the item I want to vote for. I'll create this wrapper for the database access. And then I can do dot, and non-query gives me a way to call methods that don't return any result. And then I have this dot query option, which gives me a way to call methods that return some data. And the result I'll get back is statically determined by the compiler. That's what the question mark operator returns. And that's some sequence of database rows. And when accessing, then I can write something like this, which is just like simple link query that iterates over all the options and returns a record of this poll option type that's just created by accessing the operations, the members or the columns of the row with the right name. So this example is really just a demonstration that even in the heavyweight .NET, you can get something very, very light for working with data. And I guess this is quite similar to what you could get in Ruby with Active Record or similar technologies. So that was the smallest scale at which you can work. If you just want to, if you want to specify the structure, the expected structure of the data when writing individual expressions that work with the data. And the dynamic operator or the dynamic types that are in C# or F# just give you a lightweight syntax to do it. So there's really not that much magic going on. Moving to the next scale, if you have something like the main data source of your program that's used in all sorts of different places in your program, then probably what you want to do is something like what link to SQL does to describe the structure that you expect to work with. For example, by defining some classes in C# or records in F#. Then add some hints that tell some library how to map the data that you have to your structure. So for example, in link to SQL, you'll define some classes, and then you annotate them with attributes that say how to map the database tables to your classes. And then there's some algorithm, some library that gets this description of the structure you want to get and gets this data, for example, from the database and maps the data to your structure using the hints. So I guess this is interesting because all of you, or many of you, know how this works in some specific cases, like link to SQL. But it's a more general pattern that you can use when designing your libraries or when accessing some other sources of data. So in link to SQL, it works like this. This is my description of the required structure in my C# language. It defines some class to hold the data in C# plus an annotations that tell the runtime how to get the data from database into my structure. The annotations in this case are .NET attributes, but it could be an external configuration file. That doesn't really matter. And then when you want to use it, you'll just call some runtime, some library, give it the structure description. That's my book type, and it will give me the data in the format, in the structure I specified. And I guess this is one place where you may find F# interesting, because in C# I have to describe the structure using classes. That's all I have. In F# you have, I think, a lot simpler approach to describing structure or to model your domain. So instead of like writing class for everything, you're just composing basic types and using a few simple ways. So you have some primitive values like integers, dates, or whatever. And then you can compose them into records, where a record, I already had an example of that. Record is just a structure that combines fixed number of some other values. So a book is a string, the title, a string description, plus some integer or float to represent the price. So that's one way to combine to build the data structure. And record is really just the data. It doesn't, well, actually it may have some members associated with it, but in the basic form, it's just a description of your data structure. And then you have discriminated unions, which represent construction where you have one of several options. So if you're representing shapes, then a shape is either a rectangle or a circle or let's say a polygon. In object-oriented terms, this usually means some class hierarchy. But if you're just modeling external data source or some domain where you're pretty sure how the structure looks, then implementing a class hierarchy is really it's a very complex way to describe your simple idea. So I have these three essential basic things, and I can use just these to model pretty much any data source I'll work with. So I'll make the database access demo slightly nicer. If you have some questions, please feel free to interrupt at any time. So I'll open the next version of the database example. And I'm at the same point where I was previously. But I defined my record poll options that describe the required data structure. And I'll use the query member to invoke some stored procedure. and the name of the stored procedure.
Shouldn't it be non-query?
Yeah, this should be query because load function returns some results, and the query member is used if I'm returning some results. Non-query is used when I have a call that doesn't return anything. So the query and non-query, it's slightly ugly. It's just to distinguish between the two cases when it returns something or when it just does some action and returns void. And I wrote this piece of code, and if I run it again, then hopefully after compiling all the web applications that take so long to compile, it will give me a poll application somewhere. Here it is. So this is the second version where people obviously like Visual Basic quite a lot. As you can see, it's getting the data. I can vote and everything. And how does it work? Well, the thing is that this get options, that's some dynamically called member. And in this method specification, I'm saying that the result type is IEnumerable or seek in F# of poll option. And the dynamic operator gets this type from the context. So the F# type inference basically gives the question mark operator some generic type argument, which is this poll option record. And the question mark operator, in this case, it's more clever. It looks at the required type and gets the data from the database and fits the data automatically to this record. So it does some reflection to look at the members of the record, and it matches the column names with the fields of this record. So I think I have one slide that gives slightly more details. The question mark operator, in this case, can get the type from the context, because the question mark operator is some method that's generic in the return type. It returns IEnumerable of t, and when the F# compiler sees the code, it will infer that the t is book. So the question mark operator can be clever and can fit the structure, fit the data to the structure I want. Yes?
What if you don't give it this hint, so you don't give it the return type?
Yeah. If I didn't specify the return type here, which I did using some annotations that are optional, then it would give me some compiler warning saying that it doesn't know the return type. So the way types work in F# is that you don't have to write them, but the language is strictly typed just like C#, even in some ways stricter. So everything has to have a known type. The compiler just looks at various ways you work with the data, and based on that, it infers the type. So you don't have to write the type that often, but if it fails to figure out the type, then you'll have to give it some hint, like this annotation using the colon. Okay, so that's essentially just the same thing as what link to SQL does. It's just in some ways simpler. I'm modeling the data as a record, and I'm using the question mark to say, give me the data of this form. And I guess this is interesting because it's not that difficult to implement. There was a project, one of the big successful projects of F# was Microsoft Research using F# to do some data processing on the advertisements on Bing. And they had something like, I don't know, hundreds terabytes data that they needed to process. It was so much data that it was actually cheaper to get someone on the plane with a hard drive and send the person from Redmond to Cambridge. And they used something like this to process the data. So they wrote a model using F# records, and that they used this to work with the database. So you could use exactly the same principle for working with other types of data. For example, if you have RSS feeds or some XML documents, you can model them as data. So this is using slightly different syntax than in the previous case. These are discriminated unions. But in case of RSS, it's really very simple. There's always just a single case. So RSS is essentially something called RSS, which contains a channel. Channel is something that contains title, link, description, and a list of items. If the RSS root element could contain something else than channel, then I could add other options here. I just don't need it in this example. An item contains title, link, and description. And title, link, and description are just some strings which have some additional tag so that I know whether it's a title or a link. I can find out from the type. So this is a simple domain model for my RSS feed, which is written as 6 types. And if you just imagine writing the same thing in C# as 6 classes with altogether something like 15 properties, then it definitely wouldn't fit on my slide, which is, I think, one interesting aspect of F#. Yeah, there was a question?
Yeah, if you don't list all the values, does it get an error, or does it just doesn't get with?
Yeah, so the question is, what happens if I don't list all the values? Well, in this case, currently I'm just modeling the domain. So these are some types that I could use in my program. I could build them in various ways. And I could build a parser that looks at RSS feeds and builds these data structures. And it's really a question for the parser, what it will do. So the parser I wrote, it just, if the RSS feed contains some more items, then it will just ignore them, and it will fill all of the items that I specified explicitly. But if you're programming something where missing some data would be an error, then you could write it differently. So that's my small, simple domain model of RSS feeds. And the way to use it, just like I had the dynamic database example, I have something called structural XML, which loads some XML file or URL, and it works on XML in general. And it matches the data in the XML file against the structure which was described by my domain model. So in this case, I'm loading the data using the first line, and the rest of the snippet is taking the data that was loaded and matching it against decomposing the object, the data structure, into some primitive, into the individual components. So I'm taking the RSS element, I'm extracting the channel from it, and from the channel, I get the title and the list of the items. And this is an example where the compiler can figure out what I'm doing without any type annotations, because these names like RSS and channel, they define the types, the domain model that I wrote. So the structural XML wrapper gets the type just because I'm using these constructors or deconstructors to work with the value later on. Okay, I'll show you a brief example of this. Okay, this is all implemented, so I can run the example first and talk about it later. It can get Guardian RSS feed and get some titles and descriptions. And it can also connect to my own website and give me the latest articles from the website. And my website actually has an RSS feed, but if it didn't have RSS feed, I could just scrape the XML or the HTML document that that the website returns if you go to the homepage. So this isn't working with RSS. This is scraping the HTML of the website. How does it work? Well, the first example, it's using what I demonstrated on the slide. So you have this description of RSS feed. Then we use this match construct to decompose the object, the value that we get, into the title, link, and items. And then for each item, we'll pick the title, link, and the description of the item. And we'll return some sequence or some collection containing these three values. And eventually, it will build something like this listing record, which is passed to the user interface of the web application, and that renders some HTML. But I really wanted to demonstrate that it's not just because I wrote handling of RSS. The structural XML helper can match the XML document against any structure you specify. So this is slightly more interesting example. It downloads a web page, which happens to be valid XHTML, so I can parse it as XML. If I couldn't, I would have to do some, fix the HTML, but that's a different problem. And an HTML document is just a root element HTML containing body, and body contains a list of HTML elements. So HTML elements is a list of HTML element objects, and HTML element object could be a div, a paragraph, or some heading. And the interesting thing is that div contains other HTML elements. So this is some recursive description. So you have, if you have body which contains div, that contains div, that contains div, to do all the fancy CSS styles that need hundreds of nested divs, you can just say that HTML element is a div which contains other HTML elements. So this is quite an interesting thing about the domain model, that you can not only express some fixed structure like RSS, but you can also work with structures that really don't correspond to any relational model. They're as complicated as general HTML. Okay, Any questions for this part? Good. So the key components of this approach, in general, the approach or the design pattern that you could use is that you define your structure, the required structure of your data in your programming language, and then you have something, some library, some clever tool that matches the data to this structure that you defined. And it's more, I guess it's more explicit because you explicitly define the structure, or Link to SQL generates it for you, but that's really the same case. And you match the data automatically to fit the structure that you specified. Okay, the problem is that this can fail if the model, if your description is not in sync with the data. If suddenly someone changes the structure of RSS feeds, then this application is going to fail because it cannot match the data to the structure. Or if you change the database structure without updating your Link to SQL model, you'll get an error, but that's expected. And there's really nothing not much you could do about it aside from making sure that the structure is up to date. But I guess this is the general principle that's currently used in many .NET libraries. Okay, so the next point is going to be about even larger scale. You could define the structure if it's something you're working with in your program, because you can probably match your database to some objects in your program. But when we move to the internet scale or the web scale, if you just want to access any web service or any data source that's available on the internet. So the problem in this case is that there's just too many things you may want to access from your application. If you look at some websites that provide data, this Freebase thing, that's something like typed Wikipedia. It's basically a Wikipedia which contains some types or has some annotations that describe the structure of the data. And there's something like, I selected one category and then looked at a few subcategories with the largest number of types. And there's something like maybe 400 types in this subset. And typing or even generating code for 400 types, that's probably not something you would want to do. I'm not sure how the C# compiler would deal with it. It will probably work, but. Or you may want to access some web services or web API, and this directory called programmable web contains 3,000 of APIs, which probably contain more objects. So you'll really end up with this huge number of types or objects that you would like to call from your language. And the solution, what can you do, is to stick this Babel fish into your compiler. So you'll use, the Babel fish stands for these F# type providers, as you could guess. And what it does is that it looks at well, you can read it, but it's just too scientific. What it does is that it mediates the structure. It looks at the structure of all the web services that it understands, and it translates the structure from the web services or from XML, from databases, to the structure in that your compiler works with. So it maps it to some classes or to some data types. And I'll show you an example. Hopefully it will work. I wrote it on Monday between midnight and 4 a.m. And I'll need this F# interactive window. And I'll clear the contents. So I'm using F# script files, which are, in general, very, very useful things. You just open the file. You can write whatever you want. And you select something and hit Alt-Enter to execute it. So if I say 1 + 1, I'll get 2 as the result. And this first line, that references the type provider. So that's the Babel fish. And this particular Babel fish generates this World Bank namespace. And there's .regions. And it gives me statically typed access to all the regions. So I can find my favorite region, let's say European Union. And if I evaluate it, it will give me some representations of the countries in European Union. So let's say what example did I want it to do? Let's do something else. Let's take a look at, instead of looking at regions, let's look at some individual countries. So there's an interesting country called World. And we can look at the data that we can get from the World Bank about the world. And this is something that, this lists all the indicators that the World Bank data source have about countries. And it's about 4,000 of properties. So imagine you would have to remember all the names or even generate class with all the names. And for example, we can get forest area. Now, F# uses these tick symbols to allow you to write any identifier that contains all sorts of funny names, funny symbols. So this is just accessing a property. And it will give me the forest area of the whole world at various years. So if I sort it by the year, I'll get the forest area. You can see that it's decreasing from 32% to 31% over the last 20 years. That doesn't look too good. I can write some more interesting examples. Yeah?
The intelligence auto completion, is that in the DIL, all the names, or is it
So,
does it query the
yeah,
internet?
yeah. The question is if all these IntelliSense things, all the properties are in the DLL, or how does it get it? So there's 4,000 of these in the Freebase. There's even more. There's like hundreds of thousands of these. So the DLL would have to be pretty massive. The way it works is that these are generated by the DLL. So the DLL is something clever. I'll tell you how it looks in a second. And the DLL just generates these properties. It queries the World Bank and gets a list of all the properties and then generates types for this based on the data it gets.
So if the World Bank added a set while you are querying, it would show up?
Yeah. If the World Bank added some new things since Monday, then it would show in my IntelliSense. Of course, if the World Bank removed forest area, then this code would no longer type check. I couldn't compile it because the field's just not there. So it moves the checking to slightly earlier phase in the link to SQL, when the structure changes, when the database changes, you'll find out when you next run the application. Here, you'll find out when you next compile the application or when you run it, whatever happens first.
So
Yeah?
you would also get the types from that, so you could declare a variable and use it.
Yeah, you can do things like let something like this, the type of forests. Okay, this is not such a good example. I have a better one somewhere. This is the example I wanted to get. So I can create a list of countries and just use some properties generated by the type provider. So I'm creating a list containing Greece, Ireland, and some other countries, and it will get some type that was generated. It will give me a list of values of some type that was generated by the type provider. So the types are just usual types. You can work with them in F# as with ordinary classes. The way it works internally, that depends on the type provider, but these types are really just the types from the compiler point of view, from the language point of view. Yeah, there's one more question.
What happens if your internet connection goes down while you're trying to code?
Yeah, if my internet connection goes down, then I won't get any IntelliSense in this case. It's because the type provider is poorly written. I'll have a few more points about this in the last slide. So the last example I wanted to show you is if we take, for example, Greece, and let's get finding the right one between 4,000 is a bit tricky, so I'll copy it from the snippet. So you can get, I'll also load some F# helper for charting, and this is just a lightweight wrapper over the .NET charting API with some nice F# interface. So I can download the central government depth of Greece, and I can sort it by the date, and I can show you this nice, well, not really that nice, but graph showing the national depth of Greece. Doesn't look too promising. And I can create a list of some countries that I'm interested in, and I can create a combined chart for multiple countries. So this downloads all the data for the 5 countries, and then hopefully I'll get a combined chart. It downloads the data again. And this is a chart showing some random countries that I selected. So for example, Denmark is this one. Doesn't look too good either. The bottom one is surprisingly Czech Republic. The interesting thing is that even when there's no crisis, Czech Republic still spends more than it has. So we're fine. We're still low. We'll eventually get there. Never mind. So I guess the example demonstrated that you can easily get access to all this huge amounts of data. You can, when you see this, when you see the things you can get to, you really start getting ideas of some interesting applications that you could write, and it really changes the way you think about accessing data. Yeah.
In order for this to work, would the Babelfish have to know the data source in advance, or how, could I use it? Could I apply it on any data source that I want?
Yeah. The question is, what does the Babelfish or the type provider need to know in advance about the data source? So if the data source is something that's well specified, like XML or web services, then it doesn't need details about the particular web service. If it's something with some arbitrary format, like the World Bank data structure, then it needs to know something more. And the type provider essentially is something like this interface, which has method that returns types. It returns some representation of the types that the compiler should see and that your IntelliSense should see. And it can, when it's compiled, you can replace these types that you generated or returned with some simpler code. So the example with World Bank didn't actually generate any compile time types, but it replaced all the types with some method call to some small runtime. So you will not end up with an assembly containing 5 million of types or something. Yeah?
Is the type provider a read-only? I mean, is it just for accessing data? I couldn't use it like an ORM, for example, like an Hibernate in order to access. I mean, I can get data out of my database, but I wouldn't be able to update it. Is that right?
Well, it can generate mutable types for you. So you can also generate types that allow you to mutate to change the data source. Okay. It's quite funny because you can then write type provider that allows you to change the data source or even change the structure of the data source, but then you change your types. So yeah, you can do some pretty interesting things with it. And I'll skip the last example, which was accessing all these free-base data. If you search for Don Symes' talk on type providers, he has some examples with accessing chemistry data or baseball players, whatever it's in the Wikipedia. And just to summarize, there are really, what I talked about in the talk were 3 ways of bridging the gap between the structure in the data sources and the structure in your language. Locally, you can use dynamic operators. At the program scale, you can define the structure explicitly using some domain modeling, which works very nice with F# types. And if you want to access all the data available in the world, then you'll have to use some Babelfish to translate the data for you implicitly. And that's the end. Before giving out the book, there's the little advertisement that you'll have to go through. I'll be doing, together with Phil Trelford, who works in a financial firm in London, we'll be doing some F# and functional programming training. So the first one is more about for C# programmers, explaining the functional concepts and some basic F# features. So you'll learn something even if you continue using C#. The other is more advanced F# course. If you have any questions, I'll be around, and I'll have to give the book to someone. So, Mark, do you have any idea about giving out the book as a organizer? Do you know what's the who's asked a nice question? Okay, which question do I remember? I like the question about going offline, because that happened to me yesterday, and it was quite painful. Yeah, so thanks for the question.
All right, thanks for the book.
And thanks for your attention. That's all from me today.